So this is a continuation from the previous class. So we are saying that the y component of a plus or the y component of b should give us the y component of the resultant as we found here. And we have just calculated the y component of the resultant, which is 103.923. This should be equal to 150. So the y component of a therefore is going to be 150 minus 103.9. And that is going to give us a negative 88.923. Okay, so what are we trying to find? We want to find the direction of a. So now that we know the y component of a, how about the x component of a? The x component of a, can you see we've already been given that's a negative 60 there? And so we can now say the direction, which is theta, is given by tan inverse of the y component divided by the x component. But you know, this is not the only way in which you can find. You can also, yes, please. Oh, yeah, that's true. Okay, it's because of my wrong punching. Thank you so much. 150 minus 103.923. That's how it's supposed to be operating. Sharp. Being able to analyze mathematically, it mathematically doesn't make sense, isn't it? So this is going to be 46.077. So now we can go on and be able to find the angle. The y component, so this is going to be tan inverse. The y component we have found 46.077. X component is a negative 60. So simply divide 46 divided by negative 60, then find the tan inverse of that answer. So this is given me negative 37.52 degrees. But I told us guys that when you are dealing with angles, when you find the angle, try to first see in which quadrant is a vector for which you are finding the angle is in. So you can see the x component of this same vector. Remember, this is vector A, right? We have gotten the x component and the y component. The x component was negative 60. The y component is a positive 46. So where is y positive but x is negative? It is in this quadrant, the fourth quadrant. And I told you guys that every time you find an angle, every time you punch tan inverse, you find the angle. The angle that you find is always related to the x-axis. So the angle that you found is this one. So if you were in this quadrant, the angle that we would have found is this. No, not this. Is the angle always related to the x? If it is here, the angle would have been this one, not this one. If it was here, the angle would have been this one, not this one. I want you not to forget that. It will save you some unnecessary drama. So the angle that we have found is a 37.52. So the angle that you want is this one. You always want to go in the clockwise, in the anti-clockwise direction from the positive x. So how can we find this angle? Simply add 360 to this angle that you have, or simply say 360 minus 52. And that is going to give us a 322.4775. Let's see the angle that which has been given here. Okay, this is a 142 mathematically. Okay, that doesn't add up. Okay, it's not even here. So let's confirm that again. Where could, so it's either the answer here is wrong but I know this can't be wrong after doing all these steps, really. So the y component there, y component of a 46. Okay, that's true. We've said y component. Let me just punch again this on a calculator. Tan inverse of 46.077 divided by negative 60. That is a negative 37.52. X component is negative, y component. Okay, this is y. And for this one, no one corrected me, so we were wrong together. Remember, x component is negative. Y component is not negative. Y component is positive. So this is supposed to be in which quadrant? Anyone who can tell me which quadrant is that? Second quadrant, yes. So it is here, not the other quadrant. So the angle that you found is this one, which is a 32.7.52. The negative is just telling you the direction. Every time you move in this direction, angles carry a negative sign. That's why you can see it's negative. So the angle that now we want to find is this angle here. Okay. So to the angle that we have found, in other words, just get 180, remove the angle that you have found, or just a negative 37.52, add 180. So negative 37.52 plus 180, that now gives us a 142.4775 degrees. And that's the angle there. Next question. When displacement B is added to displacement A, the resultant is a displacement C that has got component Cx, which is negative 3, Cy, that's positive 6, Cz. So this one is a vector in 3 dimension, not in 2 dimension. Displacement A and B are in the same direction, but the magnitude of A is half. You get that English. So here, what can make you feel this question is not because it's hard, it's because you don't love English. So we have got vector, we have got the x component, we have got the y component. And we've been told that vector, when displacement B is added to A, the resultant is C. So we have got A, B producing the resultant C. And we've been given the x component of C is negative 3, x component of y component. Actually, for this one, I've left out 1. We also have the z component. The y component is a positive 6, z component is a positive 4. But we've been told displacement A and B are in the same direction, meaning that if A is positive, B is also going to be positive. But the magnitude of A is only half that of B. A is half that of B. So meaning if B is 4, A is going to be 2. That is the English there. So what we are saying is that actually A is 1 over 2 B. That's the meaning. If B is 4, A is 2. So what does that mean? I can actually make a substitution. All right. I can make a substitution where there is this same thing that I've written like this. I can say, okay, let me multiply the 2 in the denominator by A. So we are going to find that B is actually 2 times A. It's the same English here. So I can say where there is B, I can put 2 times A. So I can simply remove that and say, okay, B is the same as 2 times A. So A, the x component of A is going to be AX. This is going to be AY. This is going to be AZ. How about the x component of B? Because B is the same as 2A, the x component of B is going to be 2A x, y component to be 2A y, z component to be 2A z. The reason as to why we have done this is because you can't add if you have got A and you have got B. You can only add like terms. That's mathematics, isn't it? So we can now add these guys. So what we can simply do is we are going to get the x components, we add them en masse, we add them together. So ax plus 2ax is equal to negative 3. This is going to give us 3ax being equal to negative 3. This means that the x component of a is therefore what? Divide both sides, that would be a negative 1, isn't it? And the question is, find the components of a. So we have already found the x component, and you can see that's the guy there. We can go to b. Ay plus 2ay should be equal to positive 6. This is a 3. Ay is equal to positive 6. Ay is going to be positive 2. That is that guy there. And then the z component, that will be az plus 2. Az is equal to positive 4. So this is a 3az is equal to positive 4. Divide both sides by 3. So az is going to be 4 over 3. That is that one. You can see how easy they are. If you wanted to find the components of b also, you can do that. If you wanted to find the now finding the direction here, okay. Forget about the direction because it is in 3 dimension. It's not your level here. Question 6. The three vectors A, B, and C are as shown. Find the magnitude and direction of vector D, which when added to these vectors will give a resultant of 0. So again, we're going to write vector, the x component, and the y component. Vector A, you can see it is on the negative x-axis. So meaning that this very component is the x component, but put a negative there because it's on the negative x, so 210. The y component of vector A is going to be 0 because it is on the x. If we go to vector B, the angle there you can see is 45 and it is 180. So it will be 180 cos 45. Actually 45, whether it's sin or cos, is going to give you the same answer. So 180 cos 45 is going to be giving us 127.279. So same, if you say 180 sine 45, you expect it to give you the same answer, 127.279. When you go to vector C, you can see, look at the angle that you've been given for vector C, but we don't deal with that angle in vectors. The angle that we want to deal with is the angle from here to there up to where vector C is. So you know this angle here up to here is a 270. So simply say 270 plus 60, as simple as that. I know you people cleared maths, whether syllabus D or additional mathematics, so they shouldn't be hard. So the angle there is a 330. So that is going to be, the magnitude is 110 cos 330. If we punch that, 110 cos 330, that is going to be 95.26279, and then 110 sine 330, that is going to give us a negative 55. And then find the magnitude and direction of a vector D. So we have got a vector D, but we don't know the x component of D. We don't know the y component. But the thing is that if we have got D and we add A, B, C, D, the resultant should be 0. The meaning of that is that the x component of the resultant should be 0 and the y component of the resultant should be 0. Simple English. So what are we going to do? Add the x components. The x components, I'm just going to start adding. We have got a negative 210, as you can see here. The next one, so we're going to say plus. The next one is 127.279. The next one is 95.26279. The next one is an x. So what we are simply saying is negative 210 plus 127.279 plus 95 0.26279. If you add plus x, it should give you the resultant, which is 0. So if you add the first these numbers, it will give you a 12.54179 plus x, and that will be equal to 0. So to find x, just take the 2 of the other side to be negative 12.54179. Go to the y components again. You have got 127.279 plus, that's a negative 55. You could have just said minus 55 plus, okay, I have also forgot a 0 on top there, and then plus y. They should add up to 0. So therefore this is just 127.279 minus 55. That has given me a 72.279 plus y. This is equal to 0. So y therefore is going to be, just take this number the other side, negative 72.279. So we have found the x component and the y component for our vector D. So now I want to find the magnitude and direction. The magnitude for D will be the x component of D, you square it, the y component of D, you square it, and simply square root that. So that is going to be negative 12.54179. Get this and square it, plus negative 72.279, square that and square root. So if we start, negative 12.54179 squared plus the other guy squared, and then we square root the answer. This is giving me, sorry for that, this is giving me a 73.359. This is, I don't know if it's meters or new, this is meters, right? So that is it. And then to find the direction, how can we find the direction? Anyone? Tan inverse, good. So the y component over the x component. So that will be tan inverse. The y component is a negative 72.279. The x component is negative 12.54179. And so let's punch these guys. Negative. So I'll simply say tan inverse. You know that the negatives will cancel out because you have got negative on top and down. So 72.279 divided by 12.54179. This has given me 80.156. Remember again what I told us. Try to see in which quadrant our vector D is going to lie, because both negative x and y are negative, is going to be in this quadrant. So the angle that we have found is actually here. The reason as to why it is positive is because we are going like this. All angles that go in the anti-clockwise direction are positive. So this is the 80. But the angle that we're interested in is this one. So simply get this angle and add 180. So that will be plus 180, and that is going to give us a 260.156 degrees. So let's compare magnitude 73, direction is 260. You can see those are the ones. And then, is this the last question? Okay, we have got simple questions remaining to be done. A man pulls a box with a force of 70 newtons along the positive y-axis, while a boy pulls it with a force of 50 newtons, making an angle of 80 counterclockwise with a positive y. So let's try to see what's happening. Starting with the first one, a man pulls a box with a force of 70 newtons along the positive y. So it is going upwards like that. And then the force for the man is 70 newtons. That's a man. While a boy pulls it with a force of 50 newtons, making an angle of 80 counterclockwise. Counter means anti. All right. So they are making an angle of 80, making an angle of 80 counterclockwise. Can you see that angle should be 80 counterclockwise? This is where the boy is pulling and is pulling at 50 newtons. Actually, we've been told with the positive y-axis, yes. So that's the positive y-axis, and then the angle is 80. In what direction should the second box, should the second boy apply a force of 60 newtons so that the box will move along the positive y-axis? Hint, two values are possible. Okay, so we have got a man, I'll put M, and then we have got boy 1. So we want to bring in another boy to be able to come and start pulling the box together with these who are pulling, so that the box can move along the positive y. Vectors are always easy. The English there doesn't change that the topic is easy. So vector, x component, y component. So we start with the man who is a 70 Newton, pulling at a 70 Newton force. The x component is going to be 0 because it's pulling along the y. The y component will just be the same 70. And then when we come to the 50 Newton force, remember the angle we're interested in is this one. Okay. So to find that angle, simply get 80, add 90. That is going to be what? A 170. So therefore, this is, pardon? Okay, good. So 50 cos 170. That is going to give us there a negative 49.24. And then 50 sine 70, 170, sorry. That is going to give us 8.682. Okay, so these are the ones. But we want another boy. Let me just say another boy B. We don't know who this boy is. And then we want him to pull. So we don't know his x component. We don't know his y components. The question is saying in what direction should a second boy pull? A force. Apply a force. Actually, we know the force that is applying a force of 60 newtons. So I can remove this. It should apply the force of 60 newtons, but at what direction? So that the box moves along the positive y axis. Do you get that? It should move along the positive y axis. So if it moves along the positive y axis, what is the first thing is you find the direction already. You can know the direction, isn't it? This means that this is going to be the direction. What is the direction there? If you can see what's happening. People, are we together? So you want another boy to come in, and this boy that is coming in is pulling this box also, applying a force of 60 newtons, but the box is going to move along the positive y-axis. So if something moves along the positive y-axis, what does that tell you? What is the direction? Like, what is the angle it makes with the x-axis? It's a 90, all right? It's a 90. Good. So now that is the angle 90. So we want to find the resultant force that you want to make when you add these three forces, one, two, three, should be along the y-axis. When you are putting something along the y-axis, we've said that the angle is kiste. What will be the x component there? The x component is always a zero, isn't it? Like along the y, the x component is zero. Does that make sense? But I don't know what the y component for this force is going to be. Okay, so I don't know the resultant force for the y. That one I don't know. The only thing that I know is the x, because it's going to be moving along the y. So meaning that there's going to be a certain force along the y. So therefore, if we add the x components, that is 0 plus negative 49.24 plus this x, it should give us a resultant which is a 0. This tells us that x is actually, will take 49, the other side, that will be 49.24. This is x component. Okay, but I don't know the y component. So how can I find the angle if I don't know the y component? It's hard, right? It's very hard. But we can say, remember this x that we have found is for this force here. We know that force is actually, force, the x component of a force is equal to that same force cosine the angle. So the x component of the force we have found 49.24. That is going to be equal to that same force. The force is what? 60 cosine the angle, but we don't know the angle. That's what we're trying to find, the theta. So at this point, I'm going to divide both sides by 60. So remain with cos theta is equal to 49.24 divided by 60. For me to find theta, I'll take cosine. So the cosine inverse of 49.24 over 60. Theta is going to be cosine inverse of 49.24 divided by 60. That is going to be a 34.848. So this is one possible angle. But look, in which quadrant is this angle? It is in the first quadrant. This is the angle. From your Sokato, remember the all students take coffee. Because we are dealing with cos here, the other quadrant where cos is positive is the third quadrant. The way we find angles in the second quadrant is the angle that you found in the first quadrant. Simply say 180 minus that angle. The way you find angles in this quadrant, you simply say 180 plus that same angle. The way you find angles in the third quadrant, it is 360 minus that angle. So the other angle is going to be, because this is cos, it is 360 minus 34.848. So that is 360 minus answer. That's a 325.15 degrees. So 325 and 34. You can see 34 and 325. Those are the angles there. The next question, is there any question there? Any question? Next part of the question is saying find the magnitude and direction of the force that a second man should apply so that the box does not move at all. So what should be the direction and the force the second man should apply so that the box does not move at all? You know the meaning of that is that the resultant is now totally zero. So even the ry here should be zero. That's the meaning for part 2 of the question, because it should not move, right? So to be able to find that one, the x component will be the same x component that we found earlier on, which is a 49. It will be the same because we had equated it to 0. But the y component now, we should be able to equate also to 0. So that is going to be 70 plus 8.682 plus y should be equal to 0. So 70 plus 8.682, that is a 78.682 plus y, that is equal to 0. So y is going to be equal to negative 78.682. There, so we have found the y component. But remember, the question is, what is the magnitude and direction? So let's start by finding the magnitude. So the magnitude is going to be, that is a second force. I'll just say second force from the other boy. It will be square root. We get the x component. The x component is 49.24. Square that, the y component is negative 78.682. Also square that. So 49.24 squared, 49.24 squared plus the other one squared, and then we square root that. It's given me a 92.819. That's the magnitude. The direction will be theta. That's given by tan inverse. Y component, you can see that is a negative 78.682. X component is a 49.24. So that is going to be tan inverse negative 78.682 divided by 49.24. So that has given me a negative 57.96. Again, remember, the x component of the force is positive, the y component is negative. Which quadrant is that? X component is positive, y component is negative. Which quadrant is this going to be? The fourth quadrant. Good. The angle that we have found here is actually this one. The angle that we want is this one. So how can we find this angle? Anyone? Simply add 360, isn't it? Or 360 minus that angle. So that has given me 302.04 degrees. So you can see 92 and 302. And these values are totally different. Okay, they can't even be correct. So one is saying find the magnitude and the direction. Can you see any direction here? These are all in newtons. So there's no direction. So that is not correct. That's not true. So that is how you find that other part. The last part of the question. While exploring a cave, a person starts at the entrance and moves the following successive displacements. So these displacements, are going to put them on a compass. North, south, west. Hope you remember where west is in your test or exam. End up putting west down. Okay, so she goes 75 meters north. That's the first displacement. 75 meters north. So we are going like that, and that is 75. And then 250 meters east. So takes this 10, and that's a 250 meters. 125 at an angle of 30 degrees north of west. So if we say north of west, where are we starting from? Very good. Okay, north of west. So it's supposed to be here. We are starting from the west going towards the north. So this is the 30 degrees they've given us. And this is 125. And then this is supposed to be what? North of west. and 150 meters south. So I've got 150 going down. Find the resultant displacement from the cave. Draw a rough diagram. So I've already drawn the rough diagram here. And then we want to now find the resultant. Find the resultant, first put vector, find the x component and the y component. So the first vector, we can start with the 250 meters vector. So for the 250 meters vector, you can see the x component is the same 250, the y component is 0. And then we can go to the 75 meters vector. The x component is 0, the y component will be that 75. And then we can go to the 150 meters vector. X component is 0, the y component will be negative 150 because it's going in the negative direction of y. And then we can go to the 125 meters vector. This one now we can calculate. The angle that we want to use is this one. So that's 180 minus 30, so this is 150. This is going to be 125 cos 150. And this is going to be a 62.5, and then 125 sine 150. Okay, actually the first one that I wrote, I used sine, so this is going to be 62.5. And then this one is the one for cos. That has given me a negative 108.253. So I want now to find the resultant. The resultant, simply add the x components to find the resultant in the x, the y component. So resultant in the x is going to be 250 plus 0 plus 0 plus negative 108.253. And that is going to give us 141.74. Can find the y resultant in the y. That is going to be 0 plus 75 plus negative 150 plus 62.5. So that is 75 minus 150 plus 62.5. That is given me a negative 12.5. Therefore, to find the actual error, we are going to get the x component 141.74, square that, plus the y component, which is negative 12.5, square that, and then square root 141.74 squared plus the other guy squared, and then we square root. That is going to give us 142.29 meters. The question was saying find the resultant displacement. So this question was specifically saying displacement. But if they said find the resultant vector, please, a vector should have both a magnitude and direction. So always don't forget to include the angle. Theta is going to be tan inverse of the y component, which is a negative 12.5, over the x component, which is 141. You know why? If you don't put the angle there, you are going to get few marks. So negative 12.5 divided by 141.74, and then we take the tan inverse. That is going to be giving us a negative 5.04 degrees. But remember, Rx, the resultant in the x is positive, x is positive, y is negative. So this angle is going to be in this quadrant, right, where x is positive, y is negative. The angle that we have found is this one, which is in 5. We want to find the other angle, this one here. So simply add a 360 to this angle. and that is going to give us a 354.96 degrees. This would be the complete answer if they said find the resultant vector. And that is it, my friends, on vectors.